How to construct a probability distribution with Chris. Probability distribution's definition is a description that gives the probability for each value of the random variable. It is often expressed as a graph, a table, or even a formula.
Constructing a probability distribution continues. For a table, in the left-hand column you put all the possible values of x for the problem. For the right-hand column you put the probabilities of x, the probability of the value occurring. For the graph, you put the probabilities on the y-axis, and then on the x-axis you put the possible values. In between the bars, you don't put any spacing. Down here is the probability distribution for rolling 2 dice, and that's an example. Here, 1 through 5, I cut it off because it could go to 12, but we just didn't have space. I did the fractions, and then I did the decimals, and then I graphed it, like we saw up here.
Shit! School's out!
Want to check out this graph? So 3 males with an X-linked genetic disorder have 1 child each. The random variable X is the number of children among the 3 who inherit the X-linked genetic disorder. I made a table for it. Now we're going to graph it.
Bam! 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 Chart's done.
So from the table over here, I moved on to the graph over here. On the x-axis, I put the children who inherited the genetic disorder, and then I put their probability on the y-axis. Then I started a graph. That's what I did. And then I started up here, and then I started to make a line over there. And then I made no space, which is actually a really key aspect of it. When you make a histogram, you cannot put spaces in between. So that's basically the key parts of the chart, the graph, the problem solved. That's what's up.
Requirements! Yeah. Okay, so first we gotta find the sum of p of x, and it has to equal 1, where x assumes all possible values. Sum of all values, probabilities must be 1. And 0 must be less than or equal to the probability, and the probability must be less than or equal to 1. For every individual value of x, each probability must be between 0 and 1.
Alcohol.
This is an example of a probability distribution. We have the x values and the probability that each is going to occur. So each probability is between 1, so that's like the first way that we know it's a probability distribution. And the second way is that the sum of all of these adds up to 1, so it's the second way that we know that it's a probability distribution.
Nice.
This is another example of a probability distribution. All of the probabilities are between 0 and 1, and when you add them all up, they equal to exactly 1.
Hello, I'm Tristan, and I'll be going over how to find the mean and expected value in a given probability distribution. First of all, we'd want to know that the mean is the average. Second of all, we need to know the formula, which is the sum of x times p of x. So below is an example of a chart with x on the left column and p of x on the second column. What we want to do is multiply the corresponding sides and add them all up. Here's the work for that. So the first column is 1 times 0.2, as you can see. The second column is 2 times 0.5, right there. Third column is 3 times 0.3. Okay, then what we want to do is get those numbers that are in the parentheses and add them all up. And once we add them all up, we should get 2.1. Alright, now we're going to learn about the expected value. The expected value is defined as the average value of the outcomes in a discrete problem. The formula is, again, the sum of x times p of x. Alright, we're going to do an example. If you bet $1 in a Ford lottery game, you either lose $1 or gain $4,999. The game is played by selecting a 4-digit number from 0000 to 9999. If you bet $1 on 4,356, what is your expected value of gain or loss? Now we're going to solve it. Alright, now we're going to solve the problem. First of all, you're going to want to make a chart. The first column is the event, which is either losing money or gaining money. The second column is X, which represents how much money you lose when you lose, and how much money you gain when you win. When you lose negative $1 because that's how much you pay for the ticket. When you win, you get $4,999, which is it's not $5,000 because you pay $1 for that ticket. Alright, next is P of X, which is the probability of winning and losing. The probability of losing is very high, 0.9999, and the probability of winning, gaining money, is 0.0001. Alright, so next to find the expected value, what you want to do is x times p of x for each row. For the first one, you multiply x times p of x and you get negative $0.999. Next, you multiply the next column down, or the next row down, which is the winning, and you get $0.4999. Alright, so what we want to do is add those two x times p of x's up, and you'll get negative $50, which is the total and your expected value. So here's all the work. See it again, and pretty simple.
Okay, so for my section, here are the important formulas. You have to find the mean, which was earlier stated by my colleague Tristan, the variance, and the standard deviation. Definitions. The definition of a variance is the measure of variation equal to the square of standard deviation. The definition of standard deviation is the measure of variation equal to the square root of variance. Very similar. Hi. We'll be going over variance and standard deviation. Before you find the variance or standard deviation, you have to find the mean, which was previously found by my colleague Tristan. Once the mean is found, you can plug in the info from the probability distribution into the variance formula. Then, once you find the variance, you can finally find the standard...
Deviation.
Two examples. Find the variance and standard deviation of each probability distribution. Okay, so over here, what I did first was find the mean, like I stated earlier, which is 4/3. Then I plugged in all the information that I collected from the probability distribution into my formula. Once I found the variance, I plugged that into my standard deviation formula to find the standard deviation. Over on this side, I did basically the same thing. I first found the mean, then plugged him in, subtracted it by the mean squared, found my variance, put it under the standard deviation formula, and got my standard deviation.